Assalamualaikum warahmatullahi wabarakatuh and greetings to Dr. Dr. Zul Osman. My name is Muhammad Akmal Benbrad and my ID is AA190023. So basically, we are from Group 6, Session 1 for subject DEB 40403, High Voltage Engineering. Okay, so today we would like to present to you the outcome of our project, which is the electric field distribution for 132 kilovolts class tech insulator. So basically, I, Muhammad Akmal, will present to you about the introduction, the program statement, objective, and scope of the project that we are using to accomplish our project. So without further ado, we will go straight into the introduction first. Okay, so basically in the introduction, as you can see right now, this is the insulator that is usually used in the transmission line, and this is the overhead line insulator. Okay, so basically the insulator is used to separate the support tower from the conductor. However, due to the environmental pollution, which constantly changing, okay, which constantly changing, either from rainy to sunny, or maybe in some country there are some snowpack. So the insulator can still lose its quality. Okay, so how the insulator can lose its quality? Basically, is that we know that this changing can bring can cause the contamination to be on the insulator. So the contamination that is that is on the insulator can affect the electric field distribution in this insulator. So the contamination effect can lead to the fault, the corona effect, and the flashover on overhead transmission line. So basically, our project aims is to compare the electrical performance of the insulator to other possibilities and design the installation tree based on both clean and contaminated environment. Okay. So these are the problems that usually faced by the transmission line. So number one is the poor contact insulator and transmitter, which can caused by the pollution and other factors. So number two, the transmission line are exposed to unsuitable environmental conditions, such as the winter ice, flashover, rain, lightning, fog, and thunder. Okay, so we go into the problem statement first. Okay, so for the problem statement, so the level of insulator contamination was one of the elements that is affecting the poor electrical performance of overhead transmission line. Okay, so basically, the disruption on insulator surface could result in significant issues that can put the safety of the local community at risk. So additionally, a contaminated insulator can increase the chances of lightning uh, and also the flashover. So figure this, if we don't figure a solution to this problem, there will be a lot of injuries and the maintenance expenses will increase over the time if we still using this high polluted insulation for the transmission line insulator. Okay, so we go to the objective. So basically, in the objective, our objective is to design a conceptual model of uh, extra high voltage, which is 152 kilowatt suspension type overhead line insulator. So the second one is to construct a design of glass type insulator using the finite element method, magnetic or PEM software. And last but not least is to analyze the performance of the prototype under the environmental stress and model the distribution of EHV and electrostatic field. So that's it for the objective. Now we go into the scope of the project. Okay, so for the scope of project, we will use the finite element method, magnetic or PEM software to create a 2D drawing of an insulator. And then we design a suspension insulator at 122 kilowatt level voltage, which is composed of flat insulator string. And then last but not least, we will analyze the electrical stress performance of the proposed design of the glass insulator model using the finite element analysis simulation software such as FEM software. So I think that's all for my part. So thank you very much. We go into the next part, into the simulation.
Hello, my name is Tirumurugan. My metric number is DE200101, and I'm from Group 6, Section 1. So for our project, we need to build a model of a 132 kilovolt suspension type overhead insulator. So our type of insulator is a glass type, and we are using finite element method magnetics, which is a FEM software for the simulation purpose. So now I'm going to show the simulation. So basically, this is the FEMM simulation software that we used for this project. So as we can see here, there is a node, then a segment, arc segment. This one is a block level, and then the most important thing is a mesh generator, followed by the what do you call the run analysis, and then finally the result. So for our project, we have choose the glass type insulator, which is the value is 132 kV. So basically 132 kV, we have a 8 disc. So this one is called a stacked insulator. Then there is a several simulation. This one is a insulator in a dry condition with the gradient. So basically, before we construct the insulator, we need to go to the library, and then we choose the materials that we're going to use for the construction of the insulator. For example, we are using air, glass, iron, cement, water, and aluminum. So for each material, there is a different permittivity. For example, for air, the permittivity is a 1. For glass, it is a 5.9. Iron is a 1.1. Cement is cement is a 12, followed by water, which is a 80, and then aluminum 1.5. So we can build the materials from the property definition. So we can add the property, and then we can modify the permittivity that we want. So as we zoom here, we can see the materials. For the gradient, we use for aluminum, and then followed by the insulator. So it's iron, cement, and then the body of the insulator is a glass, and then the bottom pin is iron, and then followed by the other insulator. So build until we get the stack type. Okay, and then we can run the mesh generator. And then after that, the analysis part. So basically, our simulation we are using only for the cement. We are considering the symmetrical shape of the insulator. So that's why the insulator is in a half shape. So after the analysis, we run the analysis. We can directly the result is like this. So basically, from here we can see. But before that, we need to what we call we need to set the boundary for the high voltage and also the ground. So for this one, for this insulator, the boundary is the upper part is in high voltage, and then the lower part is the bottom one is the ground. Okay, so this is basically the result. So you can see here, this part is a highly high voltage, and then the bottom one is a ground. So for the result, for the graph, we need to plot. We need to plot from the high voltage node until the bottom node. So after that, we can straight away can get the graph part, the result from the graph. Basically, this is the graph for the voltage, and then we can also get the graph for the magnitude of field intensity. So this one is basically from the starting of the graph is in a high spike, and followed by the ending of the graph, which is in a low spike. So basically, this is the for gradient stack insulator. So basically, we have several other simulation. So this one is a single disk in a dry condition and a single disk in a wet condition. So for the wet condition, we just need to add the outer part of the glass insulator with a water condition. So as we can see here, this is the for a single disk insulator for dry and a wet condition, and this is the result we can get from the simulation, and then followed by the what you call as a single disk with the gradient with the grading ring. Sorry, with the grading ring, with the grading ring, and then followed this is the result, and then followed by the contaminated condition. For the contaminated condition, we use fungus. So the value of the fungus is also stated in the simulation. Then this is the result, and then followed by the stack disk insulator. Stacked in, then for both dry and wet condition, and then the stack for the grading ring for dry condition, wet condition, and also for the contaminated condition for the stacked insulator. So basically, that is the simulation we did for this project. So that's it from me. Thank you.
A very good day, doctor. I'm Karthi Puspanathan with a matrix number of DE200101. So I'll be presenting result and discussion for my team. So we have performed 5 types of tests for the project. The first one is single disc dry and wet, stack disc dry and wet, single disc with and without grading ring, stack disc with and without grading ring. And the final one is contamination of single disc and stack. So the meaning of grading ring is, so whenever a conductor is having a flow of current, it will produce a flux. So the flux will exit the certain part and will penetrate to another conductor, nearby conductor. So we need to avoid this. So the main role of grading ring is to avoid the flux from entering another nearby conductors. So that's the reason why we'll install a grading ring in the high voltage. And the contamination is for fungus. For this project, we use fungus. So I'll begin with the presentation. So this is the drawing for single disc dry condition. So it started with the iron and followed by cement and glass and finally another iron. So the first iron is for the high voltage and the last iron is for the ground. So it's surrounded by air. So for the wet condition, we added a layer of water on top of the glass insulator. So this is the graph that we obtained. So when the length increases, the voltage decreases in both conditions. But the difference that we can observe is over here. So in dry condition, the voltage drops down drastically, while in the wet condition, it spikes up a bit, then only drastically it came down. So that's the first difference. And then the difference is in the what we call intensity. So intensity in the dry condition starts at nearly 60 mega and ended up at nearly like around 30 mega. But in wet condition, the spike started up at around 80 mega and ended up 30 mega. The final spike is same as the wet and dry, but the initial spike is very high compared to dry condition. So this is the density. The density in dry condition is nearly around 0.005, while ended at 0.002. 0.025. And for the wet condition, the spike is really high, where 0.007 and ended up at 0.003. The final spike is same for wet and dry. So this is for the contamination. So this project we use fungus as the contamination. So this is the graph. The graph can be seen like very different to the wet and dry, but somehow it managed to drop down. So there is the first part. And this is for the intensity. The intensity starts at 70 mega and ended up at 30 mega, similar to wet and dry condition. And this is for the density. Density is like it started at 0.006. For the dry condition just now, it started at 0.005, but this was slightly higher but lower than the wet condition. But the final spike is similar to both dry and wet condition. So this is the stack disc with grading ring. So the grading ring material we use is aluminum. So but for the insulator we added 8. The reason why we added 8 is because we are using 132 kV. So that's the reason why we added 8 times of the insulator. So for the wet conditions, same as how I explained for the a single disc, water has been added on top of the insulator. So this is the potential volt. When the length increases, the potential volt in both condition decreases. The difference is in the dry condition it has the drastic decrease, but in the wet condition you can see a slightly hike and down. So that's the small difference that we obtain. And then for the intensity starts at 20 mega and finished at nearly like around 10 mega. But in this condition, the initial spike is nearly 4 mega and ended up at 5 mega. So that's the difference. In this condition, initial spike is higher than the final spike, but in the wet condition is like vice versa, where the initial spike is lower than the final spike. So the ideal one is the initial spike should be higher and the the final spike should be lower. So this is for the density. For the density is started at 5 times 10 to the power of 5 and ended at 4 times 10 to the power of 4.5 times 10 to the power of 5. So and then the density in the wet condition is nearly like around 0.002 and ended at nearly around 0.001. So in this condition.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Shazwan bin Muhammad Jafri, matrix number CE200063. Okay, today I will continue the presentation with the conclusion of our assignment. Suspension insulator is tested in high voltage direct current, dry, contamination, and cement circumstance to demonstrate the polymer insulator's capacity to tolerate over voltage. It is very recommended to take a longer creep edge distance in more polluted or contaminated region than in a clean location, for such as water contamination. Then, when dealing with high voltage, we all know that the risk is very high, and we must to take safety is a highly essential in the high voltage engineering area. So, we recommend it to take extreme caution when doing the test. That's all from me. Thank you.